In a world that's always changing, how on earth do we build software that can actually keep up? Today, we're going to dive into how software development has evolved, moving way beyond those old, rigid methods to see how the most innovative products really get built. If there's just one thing you remember from this, let it be this. Building software is almost never, ever a straight line. The path from a cool idea to a product people love is, well, it's messy, it's unpredictable, and it's constantly changing. Which kind of makes you wonder, if development isn't linear, why did we spend decades pretending it was? Let's take a look at that old school approach to really understand why it so often just doesn't work. Right, so here it is. This is the waterfall model. It's this very rigid step-by-step process where you have to finish one phase completely before you can even think about starting the next. It looks great on a flowchart, all neat and organized, but in the real fast-paced world of tech, this straight line often leads you right off a cliff. And here's the fundamental problem, right? The real world just isn't a straight line. Requirements always change halfway through a project. The market zigs when you thought it would zag. Deadlines get tighter. A rigid model like this just has no way to adapt to all the twists and turns that a real project throws at you. So, what's the first common sense fix for this? Well, you build it piece by piece. And that brings us to what's called the incremental model, which is a much more practical way of doing things in the modern world. The idea here is actually brilliant because it's so simple. Instead of making everyone wait for years for one giant finished product, you release it in usable functional chunks. I mean, think about the apps on your phone. They don't just appear fully formed, right? You get updates with new features all the time. That's the incremental model right there, in your pocket. Okay, let's make this really concrete. Imagine we're building a new word processor. The very first release isn't this massive, bloated thing. Nope. It's just a simple tool that lets you type stuff and save it. It works from day one. Then, in the next increment, you add more advanced editing tools. Then you add a spelling and grammar checker. You're delivering real value early and often. And then you just build on it. And this approach, it has some huge advantages. For one, you get user feedback almost immediately, which is just priceless for making sure you're building something people actually want. It also means smaller teams can get a core product out the door without being totally overwhelmed. And you can tackle the riskiest, scariest parts of a project first to get them out of the way. All right, so building in pieces is great when you have a pretty clear roadmap. But let's ask a much tougher question. What happens when your requirements are fuzzy? When the customer has a vague idea, but the details are a total mystery. When you're facing that kind of deep uncertainty, you need a totally different strategy. And that's where evolutionary models come in. These are designed specifically for iteration, for letting the software literally grow and change as we all learn more. We're going to look at two big ones, prototyping and the spiral model. So think of these as two different tools in your toolbox. They're both for evolving software, but they solve very different kinds of problems. One helps you figure out what the target is, and the other helps you navigate a really risky path to get there. Prototyping is what you reach for when the main issue is that nobody, not you, not your customer, is really sure what the final thing should look like or feel like. So what do? You build a quick, kind of rough version, a prototype. Its only job is to be a conversation starter made out of code, something you can put in front of real users to finally get that crucial feedback and figure out what they actually need. But this leads us to the classic prototyping dilemma. See, in an ideal world, the prototype is a learning tool. You're supposed to throw it away. It's often held together with the digital equivalent of duct tape and prayers. The problem is, when stakeholders see something that looks like it works, the pressure to just clean it up a bit and release it can be enormous. They forget about all the shortcuts and compromises you made to build it so fast. This whole problem brings us to this legendary quote from the software engineer Fred Brooks: "Plan to throw one away. You will do that anyway." It's this perfect, stark reminder that a prototype's purpose is to learn. Confusing that learning tool with the final robust product, well, that's a recipe for disaster. Okay, so if prototyping is all about figuring out fuzzy requirements, what do you do when the biggest challenge isn't what to build, but how to build it without the whole thing blowing up? That's where the spiral model comes in. It kind of blends the flexibility of prototyping with the structure of the waterfall model, but it's all centered around one single core idea: managing risk. The whole process looks like a spiral, always moving outward. On that first loop, maybe you're just developing the basic concept. With each turn, you build something a little more real, a prototype, then maybe version 1.0. But the most important step in every single loop is risk assessment. You are constantly stopping to ask, what is the biggest thing that could go wrong here, and what are we going to do about it? This makes the spiral model incredibly powerful, especially for huge, complex systems. Its greatest strength is that you are constantly reevaluating and reacting to risk. But, and this is a big but, it's not a silver bullet. It can be a really tough sell to clients who want a nice, neat, predictable plan. And honestly, its success completely depends on having real, serious expertise in risk assessment on your team. So we've covered a few different models here. How do you actually choose the right one for your project? Let's try to boil this all down into a simple, practical guide. The very first and most important question you have to ask yourself is this. Are your project's requirements clear? Are they stable? Are they well-defined? Do you know with a pretty high degree of certainty what you need to build? If the answer is yes, then the incremental model is almost certainly your best bet. Your path is clear, so you can just focus on delivering value in planned, manageable pieces. Get that core product out the door fast, and then start adding more features over time.
But what if the answer is no? What if your requirements are fuzzy or ambiguous, or you just have a gut feeling that they're going to change a lot?
Well, in that case, you need an evolutionary model. And the choice between them really comes down to your primary challenge. Is your biggest goal to just define and clarify what users even want? Go with prototyping. Is your main concern navigating the crazy risks of a massive, complex project? The spiral model is your guide. And that brings us to our final thought here. All of these models we've talked about were created to adapt to a changing world. But as technology and projects get even faster and more complex, the one thing we know for sure is that our methods can't just stand still, which leaves us with a really fascinating question to ponder. How will our ways of building need to evolve next?